In the city of Mantua, there lived an adolescent named Max. As soon as he knew the national bowling playoffs are on the way, his instincts contagiously prompted him to sign up for the competition. Well, I have to say, Max has practiced to the point that he only misses a pin or two with every shot thrown. That's pretty impressive if you think about it. But Max was never satisfied and had his eyes sharp on topping over all the pins at once.
Maybe if I swap this ball with another one with twice the mass, I can get all the pins in one shot every single time. I must do all that is possible and impossible to win the competition. I have to change the ball with the metal one. It has double the mass and will help me top over all the pins.
I have doubled the mass of the outstretched ball. I can always accelerate twice as much as it.
I think I am gonna slide with the ball with the greater mass. I still have to consult my coach though. Mr. Boyer, you know I have been training for months to prepare for the upcoming bowling competition. I have put so much work into it, but I barely knocked down all the pins. I have thought of using another ball with a greater mass, but I really do not know if this is the right thing to do.
Listen there, young man. It's the right thing that you dropped here before doing anything of your detrimental ideas. I wonder where you get them from. The acceleration of the ball depends on its mass and the amount of force you apply on it. The more the mass the ball has, the more the force you will need to exert to get it move with the same acceleration as the original ball. To cause this metal ball to accelerate, you will need to apply double the force, and this will be very difficult for you. It's better to use the original ball that has half the mass. To better understand this notion, I recommend you go to Mr. Newtono, who will best explain it to you. Sir Isaac Newton first presented his three laws of motion in 1686. The first law tells us that an object at rest or an object at constant velocity will stay at rest or constant velocity unless it's affected by some net force acting on it. The third law is concerned with the action-reaction forces, while the second law tells us how the force affects that constant velocity. In case of fixed mass, it gives the famous formula F is equal to ma. Acceleration and force are vector quantities that have both magnitude and direction. Acceleration is proportional to the force applied, and the force applied is proportional to the acceleration, and that was explained by your coach. However, you shouldn't confuse mass with weight. Mass is the measure of how much matter is there, and it is measured in kilograms. Weight, on the other hand, is how much that matter is held by gravity, and it is measured in newtons. So, weight is indeed a force. An object's weight is equal to its mass times the acceleration due to gravity, which is equal to 9.8 in magnitude. Newton's second law defines force to be equal to the differential change in the momentum per unit of time. He defined momentum to be the mass of an object times its velocity. For an object like a rocket with a large change in mass during the flight due to continuous change in the mass of the propellants, we must apply the more accurate formula of the second law associated with the change in momentum. F is equal to delta m times v all divided by delta t. In order for the left side of our equation to remain in balance with the right side, acceleration of the rocket has to increase as its mass decreases. That is why a rocket starts off moving slowly and goes faster as it moves into space. I hope you understood the three laws of motion proposed by Sir Isaac Newton and how the second law of motion applies in our daily life.
Well, Max was very surprised by what the coach has just told him. So, he went over to the playoffs in hope that he can apply what the coach has just told him.